Now, to piggyback on where the last section ended, do remember that the parasympathetic control of the heart is actually enacted through the vagus nerve. And to further explain upon atropine, atropine specifically blocks the impulses from the vagus nerve itself, which is how atropine raises heart rate. And that's just a quick thing I want to throw in there. So moving forward in the nervous control of the heart, there are three main concepts that you will need to remember. Three main words is a better way to say it. Chronotropy, inotropy, and dromotropy. We describe cardiac drugs as how they affect each of these three things. So let's talk about each of them and break them down. The first one is chronotropy. Chronos meaning time. Chronotropy is the heart rate. So epinephrine has chronotropic effects because when you administer epinephrine, the heart will speed up. All right. Now, moving forward to inotropy. Inotropy is how hard the heart contracts, how hard it squeezes. A good example of a drug that affects this is called dopamine. Now, if you haven't learned about dopamine yet, don't worry, you'll get plenty of it. But dopamine is great at increasing inotropy because it actually affects the heart in such a way that it causes it to contract harder. The third one is called dromotropy. Dromotropy is the rate of nervous impulse conduction. And we use things that either speed this up or slow this down. So dopamine is another good example. Dopamine can increase dromotropic activity. Often enough when we adjust dromotropy, we're actually trying to impede it or slow it down. So a great example of that would be a calcium channel blocker like cardizem. So with cardizem, when you have certain heart rates where the heart beats too fast and in irregular fashion, you can't maintain blood pressure or it is causing the heart undue stress, we will reduce the dromotropy by blocking calcium inside the heart. And I hope that makes sense to everybody. So again, those three things are chronotropy, inotropy, and dromotropy. And you need to remember those three because we describe cardiac function and we describe cardiac medications by how they affect those three categories. So the heart is an endocrine organ. It is one that gives off neurotransmitters and hormones. It receives them. It has a lot of functions. It's more complicated than a simple pump. So it's also a pump in an endocrine organ, so it actually does give off chemicals. It has a hormonal system that it influences and obeys, and it secretes the hormones in response to the things that the body goes through or the needs that the body has. So any hemodynamic stress or diuresis, things like that can influence the heart, as well as the heart can influence its own hemodynamic abilities. It can cause diuresis. It can give off chemicals that cause other chemicals to be given off that actually can cause you to lose urine, to retain urine. It's a large and interconnected system between the heart and the brain. None of this stuff is really standalone on its own. In addition to that, it can cause vasoconstriction and dilation. The greater the stress to the heart, the greater the secretion that you are going to see of these hormones and neurotransmitters. Now, we're not going to cover all of these. We're going to cover some of the more important ones and some of the things you'll see in your textbooks and on your tests so that you can be better prepared for those, but also so you can understand some of the chemical concepts here as well. We will cover more of the myoglobin, CK, that kind of stuff a little bit later. Right now, I'm going to launch into a new block, which is going to primarily deal with the electrolyte role in the heart, and I'm going to stop this lecture and start a new one because that one can get a little bit lengthy, and I don't want to have 25 or 30-minute blocks on this. All right, so we'll get started in the next section. Measure sort of the extent of congestive heart failure patients and things like that, and to measure the extent of patients who have huge amounts of stress placed on their heart, whether it's due or undue. It's one of those things that they can go through and kind of see the cardiac markers in the bloodstream. All right, that's just one of the big ones I kind of wanted you to remember. You can also see C-type, natriuretic peptide, which is another that's going to be involved in those blood tests, and it's often used in the maintenance of electrolytes, proper fluid balances, and different things of that nature to kind of regulate the heart. Now with that, we're going to jump into the actual role of the electrolytes in the cardiac function. And this is vital to all of the treatment in cardiology. And it is important, even in pre-hospital medicine, that you understand this, because understanding how this works is the only possible way that you are going to know fully